Here. We're going to be going over some trigonometric identities here, and we've done some of these in class. We're going to add the sum and difference formulas today, but it's been a while, so let's go and review just a couple things. By the way, this website is called mathisfun.com, and I searched on there for I just typed in trig, and it took. I clicked on the trig identities because that's what we want. Right triangle. So basically, just a reminder. This is our setup, opposite, adjacent, hypotenuse. That gave us all our trigs. Adjacent over hypotenuse and all that stuff for sine, cosine, and tangent. I like this website because it's pretty clear, and sometimes the graphics here are better than what you see in the textbook. Everything we've done so far is in here, and then there's more. So some of these are like the base definitions, opposite over adjacent, all that stuff. Then there were the other ones. The tangent is actually sine over cosine. Then there was inverses like secant and cosecant and so on. And then that famous Pythagorean one. This is one we used a lot. We got a lot of mileage out of. Sine squared plus cosine squared equals 1. Blah, blah, blah. And then there's variations on that. We even did the magic hexagon. It's in here. That's really useful. We can go back to that. The even and odd ones, we'll talk about that in another section. Maybe I'll go back and review that. These are some of what we call the half angle identities and the double angle identities. Now, personally, I think those are easier to do than once we've done the sum and difference formulas. So what we're going to do is try to make sense of what these mean today and run through just a couple ideas. First of all, this is plus or minus because it could be sine of A plus B, or and then over here it'd be plus. But if it was cosine, it flip-flops. If it was plus, then it changes to minus. All right, what the hell does all that mean? Let's switch over to my camera and we'll walk through some examples. Okay, so we're going to take a look at this piece of paper, and I'm going to go ahead and try and work out some math for you here. And let me see if I can get the... I think the color's okay. So just a couple things. I don't usually ask you to memorize this, but your calculus teacher might. It's not too hard to remember. Sine A plus B goes sine, cosine, cosine, sine. That's what I remember. And then so it's sine of A, cosine of B, cosine of A, sine of B. And I'll show you where these come from. But this one's kind of tedious. It is in the book, of course, and you can look it up in the back of the book. But we're not going to focus on that right now in this video. This video will be more about how to solve these types of things. So what is this? Well, this is the sine version. And again, it is in your textbook. It's written a little bit more neatly. My apologies. But we'll try and make it clear here. So there is your sum identity. What the hell does this mean? Well, let's go back. Remember, we had two famous types of triangles. The 30, 60, 90 and the 45, 45, 90. Okay. Now, again, all this trig was developed many years ago, hundreds and hundreds of years ago, more than a couple thousand years ago, and they figured this all out. What it was, though, without calculators, how are you going to do an angle that's not quite one of these, like 15 degrees? Well, it's not one of these triangles. Or, 105 degrees, for example. Well, we can do it with doing a combination of this. So, to do like 105 degrees, this is where this trick comes in. You recognize that, hey, 105 is the same as doing 60 plus 45. And I have a formula that says when I'm adding two things inside, that's the same as doing this. Sine of 60, cosine 45, plus cosine of 60, sine of 45. What the heck? It looks bad. Don't worry. You have all the math needed. We have these triangles, and as long as you remember this stuff, we can totally push around the algebra that's required. So it's not bad at all. What the hell do I mean? Well, sine of 60 would be, from the 60, you go opposite over hypotenuse, because that's what sine is. Cosine of 45 is adjacent over hypotenuse. And that's that. Now we do cosine of 60. Cosine of 60 would be adjacent over hypotenuse. So that's 1 over 2. And sine of 45 would be opposite over hypotenuse, which also is 1 over rad 2. Okay, and then we just multiply these and add them. Now, things don't multiply and add perfectly together here, and there's a couple things we want to fix. You have a radical on top and a radical on bottom. In general, we try and keep them on top. So let's keep this one as it is. If you recall, this can be simplified into rad 2 over 2. That's the same thing. And I'll do a little side video to remind you, or we'll do a side note over here. How did we get this? Real quick little side note here on the little side cloud here. 1 over radical 2. We don't like to divide by square roots. It's not easy. It's, in fact, this is a never-ending decimal, so it's somewhat impossible. We can round it off, blah, blah, blah. It's just better if we didn't have it in the bottom. So if we multiply by itself, rad 2 over rad 2 is the same as 1 because it's the same top and bottom. Like 5 over 5, 6 over 6, 2 over 2 is 1. So we can do this, and what happens is on the top you get rad 2. On the bottom you get 2 times 2, which is rad 4. But wait, we know square root of 4. That's just 2. So the whole thing is just rad 2 over 2. Okay, so that's how we got from here to here, and that's how we converted these things. Okay, so we're not quite done yet, but rad 3 times rad 2 is rad 6 over 4. This one, 1 times rad 2 is rad 2 over 4. Now these, because they're the same denominator, we can add them. We can make them one single denominator. This over 4 plus this over 4 is rad 6 plus rad 2 over 4. And before you go one step further, no, you cannot add these radicals. Okay, so that's what's kind of a pain, is remembering which rules work for radicals and how do you mess with them and stuff like that. It does take some practice. But overall, the trigonometry is nothing more than what we did with the triangles, and then we plug in our answers here. All right, and then this stuff, it's not pretty. It's just pushing around algebra. It's just pushing symbols around. So you guys all have the skills to do this. And so now what I'm going to ask you to do is you can now try and find different angles and stuff like that. Okay, you can find things like, for example, 75 degrees. 75 degrees would be 45 plus 30. And if you're wondering, well, wait a minute. What if I thought it was 30 plus 45? Whoops, sorry, there you can read it now. Those are both the same. Now, are they really the same? Well, if you try it both ways with the formula, it will work out both ways exactly the same. So you can try it out. It will come up in the homework. There's a short assignment. Just try these out a little bit. And that's what a lot of the rest of this chapter is going to be, is a little bit of this, just identities and pushing stuff around. So it's not going to seem like the most useful stuff. It's not going to be like the most fun stuff. But it's definitely necessary. And then what we're going to get into is more just solving any type of triangle, like a 30, a 75, and a 75. That looks terrible. Okay, that doesn't look good. Anyways, but any triangle doesn't have to be one of these 30, 60, 90s. Eventually, we're moving on towards that. All right, thanks for watching. I'm going to wrap this one up because we have reached the 8-minute mark. All right. Check you later. Thanks for watching.